Hi everyone, we're going to work on drawing a Bohr model. For the purposes of our basic introductory chem class, you need to make sure that you have identified that row numbers will equal the number of rings, and your groups or the columns that go across, skipping over the transition metals in the center, those will equal the number of valence electrons you have. Valence electrons are the electrons in your outermost ring. It's also important for you to understand that the rings can hold different quantities of electrons. Our very first ring, we only have two elements in our very first row, so our very first ring can hold up to 2 electrons. Once you fill that ring, you then move on to a second ring. And for the purposes of our class, the subsequent rings are anything from ring 2 or row 2 all the way through ring 7 or row 7 can hold up to 8 electrons. As you fill one ring, you go to the next ring. So here's a trick again, using what we've already identified as those basic trends. If we were to have to draw the Bohr model for sulfur, what we first need to do is we need to find sulfur. So we're going to find sulfur right here. Sulfur is in the nonmetal side. Sulfur itself is a nonmetal. And when we look at sulfur, sulfur can be found in group number 6 and row number 3. So I can start identifying some really key information about sulfur right off the bat. Sulfur symbol is an S. It's got an atomic number of 16, so it has 16 protons. This means it also has 16 electrons under the assumption that this is a neutral atom. We're not talking about an ion as of this point. Then, after this, we can say, all right, what row is it? Because that tells me the rings. And what group is it? Because that tells me the valence electrons. So it's in the 3rd row, and it's in the 6th column or group. So when I start to draw this, I know that this means I have 3 rings and 6 electron in the last ring. I begin with my nucleus where I have 16 protons. And then I'm going to start drawing those rings around the outside. My first ring, which I know can only hold 2. My second ring, which can hold up to 8. And my third ring, which can also hold up to 8. Now, how did I know I needed 3 rings? Because right here, it is in the 3rd row, which tells me the number of rings I need. Now we're going to go in and put in our electron. The first ring can hold up to 2. The second ring can hold up to 8. And the third ring can hold up to 8. So let's fill them up as we move our way down. I can put 2 here. We like to make sure that they are symmetrical. So we'll start at our 12 o'clock and our 6 o'clock. And then for the second ring, we'll go 1, 2, 3, 4, 5, 6, 7, 8. So we filled that ring. Now I'm at 10 electron. I need 6 more. And I'm also on my last ring, which is interesting because that group number told us we're only going to have 6 electron in our last ring. I'm going to use a different color for those valence electrons just so that you can see that they're a little bit different. So we start here 1, 2, 3, 4, 5, 6. And there we are, 6 valence electrons.